Hey there, and welcome back to The Explainer. Today we're diving into the incredible journey of artificial intelligence and sound. We're going to go from those old robotic voices we all know to the unbelievably human-like conversations of today, and we'll break down exactly how Google taught its AI to talk.
So let's just get right into it. We've all been there, right? You're listening to your GPS or maybe some automated announcement. The words are fine, they're clear, but something just feels wrong. It's that classic uncanny valley of audio. It's technically speech, but it's not human. It's missing all that life, that rhythm and emotion that we just naturally have. So what was the holdup?
Well, for a long time, the methods were, let's be honest, pretty clunky. You can see here, the early rule-based systems were basically just digital parrots, with a very limited dictionary of sounds. The quality was low, and it was super slow. Then we got statistical methods, which was a step up for sure, but they still gave us that robotic, kind of monotone sound. The real game changer, the thing that changed everything, has been these modern neural networks. They delivered the whole package: high quality, super low latency, and incredible adaptability.
So how did this whole neural revolution actually happen? Well, it all started with a huge shift in thinking. And that brings us to our first section, cracking the audio code. The big idea here was to stop treating audio generation like a physics problem, trying to build a sound wave from scratch, and start treating it like a language problem.
And the absolute key to this new approach was something called acoustic tokens. The best way to think of them is like the alphabet of a brand new language, a language made entirely of sound. So instead of trying to paint this incredibly complex audio wave from nothing, the AI could now learn to speak using these tokens, which already have all the rich information of a human voice baked right in: the pitch, the tone, all the emotion.
Okay, so let's walk through how this actually works. First up, a clever tool called SoundStream takes real audio and squishes it down into these high-quality acoustic tokens. Then a different model, AudioLM, listens in and learns the structure, kind of like learning grammar. And this separation is brilliant because it separates the sound quality from the structure, making the whole system way more efficient. Now this is the magic part. Step 3, the AI starts generating new acoustic tokens, predicting the next sound in a sequence just like a language model predicts the next word in a sentence. Finally, the SoundStream decoder takes these brand new tokens and translates them back into a seamless, high-quality audio waveform.
And when you look at a raw audio waveform like this, you really get it. I mean, look at that jagged line. It's just chaos. Before acoustic tokens, trying to teach an AI to create a waveform with this much detail that also made sense for more than a fraction of a second, it was seen as almost impossible. This new language of sound was the breakthrough that finally cracked it.
All right, so the AI can now make a single, pretty amazing sounding voice. But what about a real conversation? That's a whole different ballgame. And that brings us to section 2, the leap to conversation. The next big hurdle was all about speed.
You see, the first really high-quality models, like the famous WaveNet, had this major bottleneck. They were autoregressive. And that's just a fancy way of saying they generated audio one single sound sample at a time. The quality was incredible, no doubt, but it was painfully slow and took a ridiculous amount of computing power. You can never build a real-time assistant that way. It just wasn't practical.
So the engineers came up with a new non-autoregressive approach, and the results? They were absolutely mind-blowing. The latest models can generate audio more than 40 times faster than real-time. Just think about that. 2 full minutes of conversation can be created in less than 3 seconds on just one of Google's TPU chips. This wasn't just a small step up. It was the giant leap that unlocked true, real-time conversational AI.
Of course, speed doesn't mean anything if it doesn't sound real. And this quote right here, this is the secret sauce. The model first learned from a massive library of speech data, but the real magic happened during the fine-tuning. That's where I learned from a much smaller set of unscripted conversations between actual voice actors. With all the natural pauses, the ums and the ahs, the real back and forth of how people actually talk.
All of this incredible progress in speed and realism brings us right up to the present day. So welcome to Section 3, Gemini, the AI voice director. We've gone beyond just generating speech. Now we're talking about giving creators and developers precise, fine-grained control over the final performance, kind of like a director guiding an actor on set.
And creating a believable dialogue between 2 or more speakers, as you can see here, that is way, way harder than a single monologue. You've got to maintain totally distinct and consistent voices, you have to manage the natural handoff when they take turns speaking, and you have to stop the voices from sort of bleeding into each other. It's a massive technical challenge.
And this is exactly what the latest Gemini text-to-speech models are built to do.
They give you enhanced expressivity, so the tone actually matches what you're asking for. They've got precision pacing, letting the AI speed up when things get exciting or slow down for emphasis. And the big one, seamless dialogue, making sure character voices stay consistent and distinct. It can even do this when switching between 24 different languages, which is just wild.
Okay, so this is all really cool tech, but what does it actually mean for us? Well, this technology is the engine behind a whole new wave of applications. Imagine a personal assistant whose voice isn't just a preset, but is a unique voice clone that sounds like someone you actually know and trust. Or think about tools that can take a super dense textbook and turn it into an easy-to-follow, multi-speaker discussion. It's really all about making information more accessible and our interactions with tech more natural.
You know, all of this is leading us to a really fascinating and maybe even slightly unnerving future. So let's look ahead in our final section. What's next for digital voices?
This diagram here really pulls the whole journey together perfectly. You've got the raw text coming in at the top. It goes through all this processing and modeling. That's where the emotion and speaker identity get baked in, and it all flows down to the vocoder, which creates the final audio you actually hear. What used to be a bunch of separate, clunky systems is now one slick, sophisticated, and highly controllable process from start to finish.
But, and this is a really crucial point, we're not quite there yet. Even with all these incredible leaps, a recent Google report pointed out that native English speakers could still tell something was off. They described the AI dialogue as unnatural. Some even said eerie, saying it felt like they were listening to actors reading a prepared script. That final, hard-to-define spark of spontaneous human conversation, that's still the ultimate goal.
And that leaves us with one last big question to think about. We are getting very, very close to a point where AI voices will be pretty much indistinguishable from human ones. When that day finally comes, how is our relationship with technology going to fundamentally change? What does it mean when the machines we talk to every day can respond with perfect, convincing human emotion? The conversation is really just getting started.